Okay, Assalamu alaikum, Shabab. Before I get started, okay, I would like to tell you, to ask you to do something from next class. To make it easier for me to take the attendance, I would like to ask every one of you to do two things. First, your name, which appears to me, should be the same, spelled the same way as in the blackboard. So please, if you are writing some shortcuts for your name, don't do that. I need to see the name in the blackboard when I take your attendance, similar to your name in Zoom. That's number one. And try to make it clear. Don't combine the family name with the first name, and don't make it so difficult for me to read. This is gonna make it faster to take the attendance. The second thing is it will also help if you change the profile photo of you. Now, if you look at me now, I am a host and a co-host, and I have a photo of myself. I want you to do the same. This is also going to make it easier during the term to get to know you and recognize you. Okay, Shabab, I told this in the student in the last class, and I thought I should tell you this yourself. Today, we are going to continue the discussion on bending. We will solve one problem, and then we will start the quiz toward the end. I will dedicate around 20 minutes maximum. So we'll start the quiz probably at 10:30. This will give you 15 minutes, maximum 5 more. And then I will shut off the submission. Whoever didn't. Don't give me any excuse, ya shabab. You get me?
Doctor, it will be on Blackboard, the quiz and the submission?
Yes.
Okay.
Okay. So I hope you can get away with that. All right. Now, yes, last class we had a very detailed discussion about the bending and bending stress. And in here, we have a full summary. Last time, what did we do? We discussed two conditions, okay? Two conditions, or let's say two scenarios. The first scenario, let me quickly draw this. This is Y, this is X. I need to fix this. X is supposed to be coming out. Okay. And this is Z. X, Z. This is Y. And this is X. And this is Z. Understood? Now, we discussed the situation first. When a moment is applied along the Z direction, and then there is another moment applied along the Y direction. And what did we say? We said that both moments will generate tension and compression, normal stress along the Z direction. So for example, this one will generate tension in the bottom and compression on the top. This one will generate tension in this side and compression in this side. Now, regardless of the differences, the neutral axis for this one is here, and it is the base. And the neutral axis for this is here, and it is the base. Also, we discussed this. So, I think it's a bit delayed. Okay. All right. Now, one thing remained I promised to explain to you, and we didn't have enough time, which is the name of the moment of inertia. So we agreed that the moment of inertia, I, is equal to 1/12 base by height cube. Now, for condition number one, I is equal to 1 over 12. This is going to be the base, and this one is going to be the height, right? So I'm going to call it B1 H1. So this is B1 multiplied by H1 cube. Now, since the base is along the Z direction, okay, we are going to call this IZ. IZ or IZZ, doesn't matter. We write 1 for short, just to make it easier. So for number 2, we will have I. Now here, this is along the Y direction, the base. So it's going to be called IY, which is 1 over 12 multiplied by, this is now base 2, and this is height 2. So this is number 2. So this is base 2 multiplied by height 2 cube. And as you see, the heights are different. Here, in number 1, the height is big. In number 2, the height is small. And this is why the moment of inertia become significantly different between both of them. Now, one last thing. احنا يا شباب خلاص تكلمنا عن هذا وتكلمنا عن هذا، ما يحتاج أعيده. One last thing, which is this negative sign and positive sign. Why? Why do we have a negative sign? Why is that? Let me show you this very clearly. Okay, I'm going to clean this. Let me show you very clearly why. So this condition of a cross-section, okay, which is like this. This is again X, this is Y, and this is Z. Good, ya akhwan. Now, look carefully. If I put the moment mz in a positive sense, this is positive mz. Good? Anyone would say yes? Good? Yes. Okay, good. All right. Now, والمومنت اوف انيرشيا بعد ديسكشن طويله عرفنا بانه هذا البيس صح وهذا الهايت، فما يحتاج نعقدها خلاص. This is I Z صح، وهذا هو البيس وهذا الهايت is equals to 1 over 12 BH cube. خلصنا، هذه لا بوزيتيف ولا نيجاتيف صح؟ It's always positive. It is an similar to area. Now, ايش باقي؟ باقي الواي. الآن لاحظوا يا أخوان، إذا أنا صعدت فوق وقلت أنا أبغى الواي تكون هنا، صح؟ somewhere أنا بحسب ستريس عند هذا المستوى at this level. Now, y mz is positive. Y is also positive. Will I is also positive. However, المنطقة العليا هذه under what? Compression ولا tension?
compression.
Under compression. So وش السالفة؟ المعادلة هذه كيف أخليها تعطيني نيجاتيف؟ كيف؟ ما أقدر. ما في أي شيء. الواي بوزيتيف ما أقدر أخليها نيجاتيف، والام زد بوزيتيف ما أقدر أخليها، مو بكيفي هو. فش اللي صار؟ جينا وقلنا خلاص إحنا تطوعيا voluntarily we will put the minus sign. إذا حطيتوا الماينس sign لاحظوا شو اللي راح يصير. لو نزلت تحت إيش راح يصير؟ المومنت بوزيتيف، الواي سالب negative divided by IZ, which is also positive. Okay? I said to you it is not positive, it is not negative. هو always positive. But what I'm trying to tell you إنه هذا المقدار is negative الساين له meaningless. So that's what I mean. But it is always positive. طيب ايش صار؟ اذا ضربنا هذه راح تطلع negative لانه الواي فيها negative. However, we know that the bottom side is under tension. So again, if you put the negative sign, it will help you. It will always flip the direction to the right one. This problem happened مع MZ هنا. It will not happen here. Let me quickly, although I need to move on عشان نخلص السؤال that we are going to solve together, but let me quickly prove it to you. يعني if I tell you something, but if you see it, it's something else. So this is X, this is Y, and this is Z. لاحظوا ال M acting along the Y direction, which will make, let me make this one, this will make this tension under tension. So this side is positive, this side is negative. This is compression. Now, where is the neutral axis? This is the neutral axis. Where is the height? The height is along the Z. That's why we have a Z. Now لاحظوا يا أخوان لو أخذنا this point over here, that point, هذه في التنشن side. Okay, let's see. المومنت لو كتبت المعادلة أنا بكتبها في الأعلى هنا. Y is positive. أنا خلاص سويت المومنت. The thumb is pointing toward the positive Y. Now, in here, if you move from the center to this side, okay, do you see it? It's not coming yet. Yeah. So I am moving this way. Any dimension here is going to be positive Z. So that's a positive Z. Then divided by I, Y. المعادلة كلها positive وراح يطلع معانا tension stress, which is correct. If I go to the negative side, Z will be negative. It will not be positive. It will be negative, which will give me negative stress, which is correct. تفضل يا فارس.
يزيد فضلك دكتور. دكتور هل هذه لها علاقة بالاي جي كي طريقة الحركة من اي لجي يعطينا بوزيتيف، اذا من جي لاي يعطينا نيجاتيف، صحيح؟
Well, it's very clear the moment here. Okay, احنا قاعدين نتعامل معاها stress قصدي from bending. We're dealing with it in a scalar form. However, it is very clear إنه إذا أنا حددت coordinate system وقلت لك بأنه this direction is negative Z و this direction is positive Z, إنه any point here is positive Z, any point here is a negative Z. So it's just a matter of substituting the right thing. So don't think that M, Z are magnitudes. هذا أهم حاجة. They are not magnitude.
تمام.
اوكي اذا كان في اتجاه البوزيتيف حط الماجنتيود رقم وحط الدايركشن as a sign negative or positive وانتهينا. فاذا باختصار المعادله هذه يا شباب، في المعادله هذه الجزء الثاني هذا كان adjust itself، هو بروحه عدل ما يحتاج شيء. But this part cannot. That's why we put the negative sign. خلاص يا اخوان. طبعا شو الملاحظة؟ شو الملاحظة يا شباب؟ الملاحظة المهمة اللي انا ابغاكم تنتبهوا لا. Let me clean everything. I don't want you, which is what? This positive sign. البوزيتيف sign هذه انتبهوا ترى المعادله لو بكتبها في الواقع ايش بقول؟ انا بقول سيجما اكس اوكي which is equal to minus mz y divided by iz. Then I will put plus my okay z divided by iy. Now الحين فرق انتو you see it totally different صح؟ ايه؟ لانه قاعد اقول لكم يا شباب بغض النظر عن شنو هذا positive or negative، شنو هذا positive or negative، I don't care. I don't care if this is positive or negative or this is positive or negative. I am going to add the two stresses. Add them one to one. Why? لأنه باختصار if this is the cross section, okay, اللي حيعمل moment around the z direction بيعمل لي compression here و tension here صح؟ والستريس راح يتغير، راح يصقر. فمثلا إذا أنا رسمته بهذا الطريقة راح يكون عندي distribution compression like this و tension like this صح؟ في نفس الوقت لو أنا رسمت the same cross section بس كنت أطالع من الأعلى من التوب، إيش راح يصير؟ راح أرسم الكروس section like this. هذا الضلع هو هذا صح؟ والbending around y will cause tension here and compression here. شوف اللي صار؟ اللي صار إن في نقاط راح تكون جاي لها tension and compression together، في نقاط جايها tension and tension and so on. So how do we deal with it? Let me give you a simple method, just a simple method, okay? This simple method is the following. You look at the cross section. راح ناخذ الجزء هذا ونطالع الكروس section from the front. وإيش نعمل؟ نقسم الكروس section إلى quadrant. صح؟ إحنا نعرف إنه y أقصد the base is this. This is the neutral axis. مضبوط؟ طيب بسبب إنه البندنج مومنت mz is positive راح تسوي tension هنا وتنشن هنا، وراح تسوي compression هنا compression هنا. صح ولا لا؟ صحيح ممتاز. اوكي now نيجي حق السكشن نفسه وايضا نقسمه الى 4 اقسام. now الريد هو النيوترال اكسس here. وش سوت الام هذه وش سوت عندنا خليني اعملها بكلر اخر بلو. هذه سوت عندنا تنشن هنا وتنشن هنا ونيجاتيف هنا ونيجاتيف هنا. now if you add them what would you get? look what would you get. you will get negative and positive. you will get negative negative. you will get positive positive and you will get positive negative. Do you see this? So now in general you know in normal stresses will negative will add together. It will be more negative. معناها more compression. Negative positive they will subtract each other, but positive will add to each other. So if you are a designer you should really consider focusing on here. Why? This is too much tension. والtension عادة هو اللي يعمل crack ويعمل tearing للماتيريال. We will talk about this further later. Okay يا شباب. So let's look at this example. We have only 11 minutes. So this is very interesting problem. It says that knowing that this is a clamp يا شباب, a C clamp or a vice or whatever it's called. Now the force over here is 400 Newton. As you know, if you put an object right here and you start clamping, شو اللي راح يصير؟ لما هذه راح تضغط عليه وبحكم ان احنا we assume that the clamp is rigid, as you compress it, the body will react opposite direction by the same force. That's why we have two forces. Now the clamp the clamp يا شباب has a cross section AA شايفينه AA which is here. This is section AA. So the clamp هذا الside هو here on the top. This one is the one in the bottom, I mean below it, and this is over here. Okay, so if you would to imagine, you would imagine that point A is somewhere here, point B is somewhere here, and point D is somewhere in the bottom. Good. Now we have been given the cross section and we want to determine the stresses. لاحظ, the stress at point A and D. That's what we want. Good, يا أخوان. So let me quickly, just take 1 second. Just give me 1 second. I need to pull the slide from my computer. So. Okay, so what are we gonna do, ya shabab? We are going first to establish the understanding of the problem. Okay, so let me tell you how are we gonna do that. First, we would imagine that the clamp over here, as usual, the X is in this direction, the Y is in this direction, and the Z is in this direction. If you look at this carefully, when I make the X in this direction, I am letting the X pop up out of the normal section. Okay, so what does that mean? It means that this is the y-axis, صح? This is the x-axis, وزي العادة الزد راح يكون بالاتجاه هذا. Sorry, this is the x. Okay, this is what will happen. Good, يا أخوان.
Yes.
Okay, okay, good. Now, the next thing is, لو تتخيلون الآن إنه الفورس هذه will cause a bending in this direction and bending in this direction, صح ولا لا؟
صحيح.
صح. So if you try to use your thumb and make, you know, connecting this direction, it has to be along the Z direction. But in reality, the moment is gonna act clockwise, and for that reason, the moment your thumb will be pointing toward the negative Z, not the positive Z. So, what will happen if I would want to
can you repeat what you said, Doctor?
draw the moment in here? Yeah, I know it will be confusing. Look carefully, يا أخوان. This is the line. This force is causing moment in this direction. Now, just imagine this is X, this is Y, and this is Z. If you use your hand, okay, and rotate your right hand and rotate in this direction with your fingers, your thumb will point toward the negative Z. صح ولا لا؟
Yes. صحيح.
خلاص. ايش صار يعني؟ يعني معناها انه المومنت is acting along the negative Z. صح؟ فش اللي راح يصير؟ اللي راح يصير انه the negative Z means it is like this. That's the moment. It is acting in the such that your thumb will point toward the negative. Now, when the moment rotate in this direction, شو اللي راح يصير؟ راح تخلي الجزء هذا positive وهذا negative.
Tension compression. طيب يا دكتور،
نعم.
لو كان السكشن اللي سواه في سهمين للسكشن اللي سواه الاي اي، لو كانت في الجهه الثانيه راح يكون عكس، راح يكون موجه للزد، صح؟ بوزيتيف زد. السكشن لو انه جاء اخذه من اليسار مو من اليمين.
صحيح.
ايه اوكي تمام.
اوكي طيب يا اخوان، فاذا ايش اللي راح يصير معنا؟ اللي راح يصير بانه احنا في الحقيقه راح يكون الكروس اكشن هذا. This is another trick about this problem. الكروس اكشن هذا لو جينا وقطعناه ايش راح يصير؟ راح يصير شكله كذا. اوكي، وفي طبعا هنا السبورت حقت الاي بيم. فاللي راح يصير انه انا اذا طالعت هذا الكروس اكشن لحظه، I don't have space over here. If I look at this cross section, it will be under tension because of B, and it will be under compression on the top and tension in the bottom. Sorry, I flipped it. It will be under tension at the top, as we said, and compression at the bottom. Why do I have the normal distribution? Well, ya shabab, if you cut the cross section over here, okay, then the cross section لازم تعوض عنه force opposite to P and moment opposite to the applied moment. صح ولا لا؟
صحيح.
صحيح.
So you will end up with a bending, a reaction force and a reaction moment. And I think many of you will forget that the P will act. يعني هنا البي سببت لنا مشكلتين. المشكلة الأولى إن هي عملت tension، والمشكلة الثانية إن because the P is eccentric with a distance 50 millimeter from the cross section، إيش صار؟ أنتجت لنا moment. Two product of the force. This is not the first time يا شباب. It will always happen that one single force sometimes cause bending or torsion or tension at one cross section, especially when you have component أشياء متعرجة محنية ملتوية. Do you understand me? Okay. Yes. I think this is good enough. Unfortunately, I cannot solve the problem. I'm gonna stop here. I'm gonna give you 1 minute now to access the blackboard. Please just don't pay attention now to the slides. Go to the blackboard, ya akhwan. And when you go to the blackboard, you will go to assessment and test. On the left-hand side. Do you want me to show it to you, or do you know how to go to it?
We know.
Anyone? You know. Okay, good. Now, there is nothing there now. And in a second, okay, I will make it available. It is now available. Each one can go now and click on quiz number 1. And then you can begin the test. You will have the solution each one of you will have a problem, sorry, not a solution. Each one of you will have a problem. Let me read it quickly with you. The beam shown in the figure is subjected to the forces, actually, it's a spelling mistake, in kilonewtons, such that you have been given P1, B2, B3 as in the figure, and then you will have to draw the free body diagram, find the reactions, draw the shear force diagram, draw the bending moment diagram. I have to warn you, ya shabab, that the values are different for each student, so please be careful. It is randomized. I don't know what would you get. Do you get me? Please, when you solve the problem, make sure you write number 1, and then you solve, you put a line. Number 2, you solve, you put a line, so it becomes easier for me to mark. Best of luck, ya akhwan. Anyone is having any problem, let me know, I am here.
Doctor,
Yes.
the point at the far left is A, and the next one is C. Is that correct? The far left is A, and the next one is C.
Yes.
Okay.
And then D, and then E, and then B.
Okay.
C is located at the reaction.
Okay.